All right. Hello, everyone. How is everyone today? Just like put a reaction, I guess. All right. So today we'll be doing math, mostly radicals and rational exponents. So what are exponential expressions? So exponential expressions are algebraic expressions with a coefficient, one or more variables, and one or more exponents. For example, 3x to the fourth is an exponential expression, with 3 being the coefficient, the number that is next to the variable, x being the base, which is the variable itself, and 4 being the exponent. In 3x to the fourth, 3 is multiplied by x 4 times. An expression can also be raised to an exponent. For example, 3x can be raised to the fourth power. So the expression is 3x multiplying by itself by 4. Something to note is that like 3x to the fourth is not equal to parentheses 3x parentheses to the fourth, because in one of them you're only multiplying x by itself 4 times, but in the other one you're multiplying the entire equation by itself 4 times. So what are rational exponents? Rational exponents refer to exponents that are and can be represented as fractions, such as like 1/2. I forget the 3. Well, technically the 3 as well, 3/1, and the -2/3 are all considered rational exponents. Radicals are another way to write rational exponents. For example, x to the 1/2 and square root of x are equivalent. On the side is just a graph of, I guess, a radical. Oh no, an exponential equation. So rules for exponent operations. So when adding and subtracting exponential equations, we're essentially just combining like terms. That means we can only combine exponential expressions with both that have both the same base and the same exponent. For example, if you have ax of n plus or minus bx of n, then it's the same thing as a plus or minus b, depends on what you have in the first half of it, times x to the n. For multiplying and dividing exponential expressions, when multiplying two exponential expressions with the same base, we keep the base the same and multiply the coefficients and then add the exponents. Similarly, when dividing two exponential expressions with the same base, we keep the base same and subtract the exponents. So for example, you have ax of m times bx of n. You do a times b times x plus x to the m plus n. So in this case, it could be like 3x to 5 times 4x to 6. So you do 3 times 5 times x, and then whatever the exponents were. I forgot what I said for the exponents, but we'll leave it at that. For dividing, it would be ax of m over bx of n, which is the same as a over b times x minus n. So for exponents, I guess multiplication is the same as adding the exponents. So when you have an exponent on one side, I'm gonna use my annotation tool. So when you have an exponent on this side and an exponent here, and this is the same as well as this, you can just add the two exponents together, n plus n. It's the opposite for division. When the two variables are the same, you can just subtract the two exponents. So when multiplying or dividing exponents with exponential expressions with like the same exponent but different bases, we multiply or divide the bases and keep the exponents the same. Basically, what this means is, so x to the n, x to the n times y to the n is the same as x times y to the n, because essentially these two exponents are the same and we're multiplying this and this. Therefore, we can just put these two together and put the n on the outside, multiplying the whole thing. I mean, being the exponent of the whole expression. It's the opposite for division. Well, it's the same for division. When you have x over y and you have both of them have the same exponent, you can just take the exponent out entirely and put it outside of everything. So you only need one of these. That turns into that. Right. If you guys have any questions, just raise your hand. I'll stop and explain whatever questions you guys have. So raising an exponential expression to an exponent and change of base. So when raising an exponential expression to an exponent, you have to raise the coefficient of the expression to the exponent and keep the base the same and multiply the two exponents. So what this means is when you have a of x, when you have a of x of m, and you're multiplying n by the whole thing, you can basically, I guess it's like foiling, it's similar to foiling. You can put this on this side and you foil that way too. So you have a of n times x of m of n. It's basically you're splitting apart the original equation into this. How you could also do it's the same either way. You can turn this part of the expression into this, and this part of the expression into this. It doesn't really matter. They're the same, yeah, either way. So when the bases are numbers, we can use a similar rule to change the base of an exponential expression. For example, like when you have a number, I guess, a of b to the whole thing by n, just a of b of n, you multiply these, unlike adding, where if you have what was the example for it, adding? So apparently my thing is cutting out a little bit. Can you wait a second? Apparently we're getting some technical difficulties with what I'm saying. Sorry about that. We're running into some technical issues right now. All right. Let's see if that fixed whatever was wrong with my voice, apparently. All right. So where did my voice start cutting out? All right, so apparently my voice was cutting out for some people. So I guess I have to redo this slide. So can you guys hear me correctly now? I know, look, for most of you, I'm pretty sure it didn't cut out, but apparently for some people it was cutting out a little bit. All right. So I guess we'll go back to the start of the slide. So raising an exponential expression to an exponent and change of base. So when like raising an exponential expression to an exponent, you have to raise the coefficient of the expression to the exponent. And you have to keep the base the same while multiplying the two exponents. So for example, when you have a of x of m, the whole thing raised to n, you can just make that a of n times x of m of n. Basically what this is doing is you're technically just foiling and splitting them apart. You're multiplying the n to the a as well as the s to the m. And you can think of it like this. You have a to the first and x to the m all over n. And that's basically equal to a to the n times m to the mn. Because what you do when you have, I guess, a situation like this, you multiply the outside exponent with whatever's inside. And if there is no exponent, you just assume that there's an exponent of 1 there, because that just means the number is the same. So when the bases are numbers, we can use a similar rule to change the base of the exponential expression. So for example, you have a to the b to the n equals to a to the b of n. This is because, as I said before, when you have an exponent outside, you just multiply it with whatever exponents are inside, and you get a to the b of n. So negative exponents. A base raised to a negative exponent is equivalent to 1 divided by the base raised to the exponent without the negative sign. So what that means is you have x to the negative n. What you do here is you put a 1 over x to get rid of the negative sign here, and you still have the exponent n. So all that means is, well, you can write it out a different way. So you have what? X to the negative 1 times n. This negative 1 basically makes you put a 1 on top, and then you multiply the x by, you raise the x to n still. So a 0 exponent. A non-zero base raised to the exponent of 0 is equal to 1. So x is 0, no matter what x is other than 0, is always going to be 1. When x is 0, 0 to the 0 is actually 1. I'm not entirely sure why, but I remember having to look this up a while ago when I was preparing for the SAT. 0 to the 0 is 1, although I'm pretty sure they don't test it. All right. So I'll give you guys a good minute and a half to do this problem. It shouldn't take you that long, and I'll do this right after. All right, I guess I'll start doing this problem now. Oh, oops again. All right. So the way we do this problem. So which of the following is equivalent to x to the third times 3x to the fifth? So as we said before, when you have ax to m times bx to n, what you do is you multiply a and b, and you add m and n. So you have in this case 2 times 3 times x still, because they're both multiplied still, and you have m plus n, which in this case is 3 and 5. So you have I believe 3 here, so 6 times x to the 8th, and that is b. Any questions? No? All right. I'll give you guys a minute to do this one as well. All right, I'll give you guys 30 seconds and then do this problem myself. Ton of organizations, I guess.
Hello? Hello, I have a question.
Yeah.
So basically in terms of this, where we can see that, so like if you're solving for X, right? The other
Mhm.
part goes to the other side, right? So then would it be
Oh, wait, so don't say the answer. I'll solve this out. And if you solve a question, then you can just raise your hand and I'll answer it.
Yeah.
And lower your hand, please. After. All right. So for this question, so you have x to the third equals to y of 9. What you're trying to do is you're supposed to isolate for x. You have to have x equals to something. So what I would do in this is I would multiply exponents onto it. So you have x to the third times 1/3 equals to y to the 9th. And this is also multiplied by 1/3. So this and this cancel out because 3 times 1/3 is 1 and x to the 1 is just x. And 9 times 1/3 is just 3. So you have x equals to y to the third. Any questions? And that would be C. Megan?
So for this one, do you choose 1/3 because the exponent is 3?
Yeah, I'm trying to eliminate whatever else other than x is on the x side and just get x equals to something as I wrote right here.
Okay, so you have to choose a fraction based off what the exponent is.
Yeah, if it's a problem like this, you choose a fraction that would cancel out whatever is here. And you just multiply it on both sides because that's how math works.
Okay, thank you.
Last Rita?
Yeah, so I didn't really understand. Why are you multiplying it by 1/3?
Because what I'm doing is, so 3 times 1/3 is 1, right?
Right.
And so basically, and x to the first is still just x, right?
Uh-huh.
So what I'm doing is I'm canceling out the 3 right here by multiplying 1/3 on both sides. So I only have x on one side and like y to the 9th times 1/3. And that would give me my answer because I'm isolating for x.
Okay, so you multiply the 1/3 on the 9 side too because you have to do like on both sides?
Yeah. And we're not multiplying, we're doing an exponent of, I guess, raising the power of.
Okay. All right, thank you.
All right. Anyone else have a question? And yeah, as someone said in the chat, it's the same as doing the cube root of. 1/3 is the cube root. So another way I could have written it was x to the third cube root equals to cube root of y to the 9th. This and this cancel out, and this and this. So 9 divided by 3 is 3. So you have x equals to y to the third. Same way. 3.
So for like I understood like the process you did, but like where'd you get the 1/3 from?
I multiplied 1/3 on both sides. So this is like a way of just doing math. So you can just add an extra, I guess, like term to the equation when you do it on both sides. Because if you were to just like remove the 1/3, it's the same equation, right?
Yeah, but like where'd you get the 1/3 from though? Like wouldn't it be just 9 minus 3?
Well, no.
Why?
So the 1/3 is just I guess like an exponent I added manually, like it's an outside exponent for the equation, just to get rid of the 3. And I added it on both sides, so I keep the equation balanced.
Okay, but like couldn't you use like 2/3?
Well, yes, but that would equal to like x equals to 2 equals to y 9 of 2/3, and that is just a lot more work than just doing that.
Yeah, but so like on the SAT, right? When I take it, so you recommend me just to use a number 1/3 for these type of questions, or could I use like
No, so this
1/10?
depends on what number is right here. If it was like x equals to 2,
Yeah.
would say raise it to 1/2.
Okay, but like you could use 2 and 2 if you wanted.
If you wanted, you could. It's just a lot more work than needed.
But like 1/2 is easier.
Well, yes, but like the reason I'm doing 1/3 is because it's x equals x to the third, and the 1/3 here cancels out the 3.
Okay, but like if suppose let's say the x, right, it was x to the 4th and y
Yeah.
equals 9, then I'll use 1/4.
Yeah.
Okay, yep, makes sense. Thank you.
All right. So someone wanted me to go over this question again. Also, could you lower your hand after you're done?
Yeah, no problem. Thank you.
Mhm. All right. So you have x equals to the third, x to the third equals y to the 9th. So I'll do a different way of doing it this time, or we can do the same way, but either way is the same thing. So I'm doing x to the third minus, to the power of 1/3 equals y to the 9th to the power of 1/3. I'm doing this because I want to cancel out the 3 with the 1/3, and 1/3 times 9 is y to the third, and you have x on this side, and therefore that's your answer. Another way of doing this, instead of doing 1/3, is to do the cube root of x to the third equals to the cube root of y to the 9th. And it's the same thing. A cube root is 1/3. When you raise anything to 1/3, that's a cube root. It's just a different way of writing it. I guess it could be easier for some people. The 3's cancel out, and the 9 divided by 3 is just 3. So you have x equals to y to the third. Karen?
Is it possible for us to have exponential, can we have fraction as exponents?
Yeah. So as I just said, if you have like x to the 1/3, that is quite literally just cube root of x.
Okay, thank you.
And if it's like x to the 1/4, it's just like 4th root of x. Do you think? I'm sorry if I pronounced your name wrong. Do you see?
Yeah, hi. Can you hear me?
Yeah.
Okay, great. I just had a quick question.
Mhm.
Instead of doing all that, couldn't you just like divide by 3? Like x is to the power of 3, right? So can't you just divide by 3 on both sides and just get y equals to the power of 3?
So you're saying like x to the third is divided by 3 equals to y to the 9th divided by 3?
Yeah, and just get like y to the power of 3
That
as your
doesn't work.
answer.
That wouldn't work because the division by 3 is affecting this and not this.
Okay, that makes more sense. Thank you.
Nikita?
So let's say if I was like doing this on a test and I had to show my work, if I'm writing like the cube root of 3, can I just like write x squared to like the third power instead of like writing 3 the way you did it?
I mean, so what do you mean? So you have x to the third
No,
and you use this, right?
no. What I mean is just like you know how you like wrote the 3 like on the right.
This?
Yeah, like that. Like can't you just like it? Like that's also it's also correct if I
Oh, the reason I do
write.
that is because if you don't have a 3 here, that's the square root.
What if I wrote the
Which is-
square root of 1/3 instead of that? What
What?
is assuming this? What if I instead wrote like the square root of like 1/3? I wrote like no
That?
no.
Okay, so like this, I'm guessing. Square root of what, x, and then 1/3.
Yeah.
That doesn't work because it's
Yeah.
still square root. That would become, that is, oh my god, it's not working. That's x to the 1/2 times x to the 1 times 1/3. That's not right.
Oh, okay.
Vijay? Vijay? VA. I saw the I as Vijay. Oh, I don't think you unmuted yourself. Okay, so how did I get the 1/3? So when you have x to the third equals y to the ninth, what I'm doing is I'm trying to get rid of this 3, right? So I raised both sides to the 1/3 in order to get rid of the 3 here, because 3 times 1/3 is 1 and x to the 1 is just x. So this 1/3 is just something I artificially added to the equation so I can get rid of the 3. And the reason I am allowed to do that is because I added it to both sides. And if you were to just remove both of these, it's the same equation because they cancel out technically. All right, any other questions? No? All right, we'll move on to polynomials. So a polynomial expression is like has one or more terms with a coefficient, a variable base, and an exponent. On the SAT, you'll see 1 to 3 questions that test your ability to add, subtract, and multiply polynomials. In addition, you'll probably see polynomial expressions as like part of other passport to advanced math questions. And the 3 types of polynomials on the SAT are gonna be monomial, binomial, and trinomial questions. And these will probably be the only ones, unless like you're not going to be asked to graph a power to the 4th. I mean, you're not going to be asked. Well, these are the most common ones on the SAT. I'm going to leave it at that. It's pretty hard to explain, but these are the 3 types you're going to see in the SAT. So I'm going to go straight into practice problems because that's how I know how to explain it the best. Do you guys want to do this first and then have me explain it, or do you want me to just explain it first and then you guys do it? Raise your hand if you guys want me to do it first and then you guys do it. All right, raise your hand if you guys want to do it yourselves and then I can do it after. All right, yeah, you guys could do it. I will do it after you guys do it. I'll give you guys a minute to do it. For the people who are asking for the slides, this should be it. I'm pretty sure there's 20 classes overall, and we're on our 8th right now. Pavan, do you have a question?
Oh, sorry, I just forgot to lower my hand.
All right. Could you not write on screen? That would be nice. All right, I'm just gonna remove that permission. I'm not sure why that was there. There. I'll give you guys another 30 seconds to do this. Yes, we did skip one class, and that's the class. This is last week's class, I guess. So we're extending everything by a week, basically. All right. I guess I'll start doing it now. So you want the sum of these 2 equations. So a way you could write it, an easy way of doing this is to write x squared plus 5 plus 2x squared plus 4x. So you combine like terms, x squared and 2x, you have 3x squared plus 4x because there's no other x plus 5. And I guess like you don't even really need to write all of this. What you do is you combine like terms, x squared and 2x squared, and then you have your plus 4x, and there's nothing else to combine it with. You just leave it there, and the plus 5. So you would have 3x squared plus 4x plus 5, which is a. All right. Any questions? No? All right. Here's another practice problem. This one's with multiplication. I'll give you guys a minute and a half to do this one as well. So for people who wanted like for the person who asked for YouTube material, so I don't personally have any. However, if you do go online, you search up like SAT math practice and stuff like that, there are people who have like entire, I guess, recordings of SAT practice tests that they did, and you'll just see practical applications of what like on the actual SAT test material, I guess. Of course, these are straight from the SAT. I got these from sources that I found. But if you want like an entire SAT math section or an SAT reading section, just go on like YouTube or just like search up online for them, and you'll find a couple. All right, I'll give you guys another 30 seconds to do this one. So that would most likely just be I guess for the previous question, that would I have a link for that one. I mean, well, no, that link doesn't explain it either, but so the 1/3, I guess you could just search up exponent, I guess like exponential equation rules and such. You should be able to find it online. I don't entirely know a specific link for it. However, you should just be able to find it online. It's just a common, I guess, like a rule for exponents. And if you just search up exponential rules, you should be able to find it. All right, so I'll start this question now. So you have x to the third plus times 2x minus 5. So the best way of doing this is FOIL. So you have x times 2x plus x times -5 plus 3 times 2x minus, actually no, plus 3 times -5. And this all goes out to, so you have x, so you have 2x, 1 plus 1, because you're multiplying x by x to the first, x to the first, so it's just 2x squared, I guess, 2x squared minus 5x, -5 times x, plus 6x, 2 times 3 is 6, 6x, minus 15. And that, if you combine like terms, you have 2x plus x minus 15, and that would be answer choice C. Any questions? No? All right, we'll move on. So yeah, any questions about what I did so far? No? All right, practice problems times. So I'll give you guys a minute to do this one, a minute and a half to do this one as well. This one is a bit tricky if you don't like go the way that's recommended. And I don't really expect you guys to get this immediately. It's fine if you guys get it wrong. I'll explain this right after. So this one is an SAT level question for sure. This is like one I would expect to find on an SAT, probably a bit on the harder side. Most of these are on the SAT, like some of these are easier than others, of course, but most of the ones I do find are from the SAT itself. So there was not a class last week. However, however, the recordings for the previous classes are there. We will post the recordings for this class probably soon after this class ends. And yeah. We'll give you guys another 30 seconds to do this problem. There was no class last week because something came up for me. There was like, I couldn't really avoid it. So I had to cancel class last week. Sorry about that. It was just something for school. I had to go do something. All right, so I guess I'll do this problem. So first thing is, this problem looks hard, like off the bat, it looks like it's a hard problem. However, it's a lot easier once you realize 8 is really just 2 to the third. So you have 2 to the third times x times 2 to y, I guess. And as I said before, that is when you do have, I guess, division signs. For exponents, you could just, if the spaces are the same, these were the same, you could just do 2 times, oh wait, not, it's multiplication here, not subtraction, 3x minus y. And if you look right here, 3x minus y is 12, therefore it's 2 to the 12th. And that is answer choice A. Any questions? Also, yeah, it is tough, I won't lie. However, I guess like it's just something that I wanted to do, so I went for it. Oh, the question was like, what is it like going to the best high school in America? And is it challenging? Yes, it is, but it's something I chose to do. And yeah. Okay, so for the people who asked me to do it again, 1 second. All right, so you have, first thing, this problem looks tough again. And you have, see, you know, 8, well, 2 to the third is 8. That is like the first thing, I guess, to make this problem a lot easier than is 2 to the third is 8. So you can replace the 8 with 2/3 and multiply the x because it's already there. So times x over 2 to the y. And that's the same as we said before, because of exponent rules. You have 2 to the 3x minus y, because when you have division like this, you could just subtract the bottom exponent if the bases are the same. And we know 3x minus y is 12 because that's what it says right here. So the answer is 2 to the 12th, and that is A. Meghna?
So do you change 8 to the third to get like basis so you can combine the exponents?
Yep. It makes it a lot easier. I'm not sure if there's another way to do it. And yeah.
Okay, thanks.
So for the person who's asking, is there applications to get in? I'm not entirely sure. No, actually, no, there is. There is an application to get in. However, yeah, there's an application to get it. You have to, I'm pretty sure the requirements are you have to live in the state of Virginia and be one of the participating counties to get in. They were asking for applications for the high school I go to, which is Thomas Jefferson High School for Science and Technology. It's, I guess, like it's like a magnet school, and you do need to like go through some stuff to get into it. Subramaniam.
Yeah. For the division part, did you like substitute? Did you use the substitution method? For
No, so
y?
if you go back a couple of slides, there is like something right here, I believe. Yeah, no, right here. When you have a division sign and the bases, like the x is here is equal, you just forget about this. Think of the 2 as the x, and you have the 3x and y in here, and you can just do base, and you have your 3x, I guess, minus y.
Yeah, but how'd you get x as the 2?
Because if we go back to that problem, this problem looks impossible, first of all, simply because there's no common things, but 8 is 2 to the third. And 3 times x, because the x is already here, over 2 to the y. And as I said before, 2 is the base, because there's no, I guess, variable. So you have 2 to the 3x minus y, because the rule I just went back for. And you know 3x minus y, as it says right here, is 12. Therefore, the answer is 2 to the 12th.
Oh, makes sense. Yep. So the answer is the value cannot be determined from the information given, right?
No, look, 2 to the 12th right here.
Oh, my bad. Never mind. Yep. Thank you.
Yep. All right, any other questions? Oh, could you lower your hand after you're done? That'd be nice. All right, next problem. I'll give you guys around a minute, maybe a minute and a half to do this one as well. All right, I'll give you guys another 30 seconds to do this problem. All right, so first thing we see is we're trying to simplify this entire equation because none of these questions right here are like the answer. There's like no numbers here, like only numbers. So first thing we want to do is get rid of this like really big denominator. This makes it a lot harder than it should be. So we multiply the whole thing, 1 over 1 plus 1, or x plus 2 over x plus 2. We multiply this entire thing by x plus 2 times x plus 3 over x plus 2 times x plus 3. What this does is it gets rid of like, so first of all, this becomes x plus 2 over x plus 3 over x plus 2 over times x plus 3 over x plus 2 plus x plus 2 times x plus 3 over x plus, wait, oh, it's x plus 3 here. Oops, x plus 3. And what happens here is you cancel out these two because they're multiplied, and you can cancel them out now. You cancel out these two, and you get x plus 2 times x plus 3 over x plus 3 plus x plus 2. And if you FOIL, you get x squared plus 2x. Because I'm also for the person who's asking, why did I get the x this over here? It's because I multiplied this to here and this to here. I just ignored this for now. I multiplied those two there. So you have x plus 2 plus x 3x plus 6 over 2x plus 5, like terms, 2 here and 5 here. And combine line terms again. So x squared plus 5x plus 6 over 2x plus 5. And that is answer B. Any questions? Could you like raise your hand and like say it out loud? That would be nice, because I'm not sure where you're referring to. Anyways, Sriram.
So in the question, it was like, if x is greater than 3, could we just like ignore it and then just go to simplify?
Yeah, because we're not getting an answer for x. Like it was like, if the answer was like x equals like 2 or something, then we would say, oh no, this isn't correct because it's not greater than 3. However, we're going for like something like this.
Right.
You can just ignore this.
Okay, thank you.
So how is it B? So I guess I can do the question again if you guys want me to. Before that, does anyone have any questions about what I just did before I read you this question again? There might be other ways of doing this. However, this is by far the simplest and easiest way of doing it, because after you do the first part, it's just algebra. You just know when to cancel stuff out and such. Right, I'll redo this problem. So you have x to the 1 over x plus 2 plus 1 over x plus 3. I wouldn't do that because when you plug in a value for x, sure, you could do it, but do you really want to do like 1 over 4 plus 2 and like write all that out and such? And if you don't write it out, risk getting it wrong because you added something wrong, or would you? It's easier just to do it this way. All right, so you have this. So what I did here is I multiplied x plus 2 times x plus 3, because think about it. You multiply by x plus 2 to get rid of this one, and you multiply by x plus 3 to get rid of this one. So you have to multiply by both of those separate stuff. So I'd multiply it on both numerator and denominator, because that's how you're supposed to do it. And with that, I get x plus 2 times x plus 3, because this goes on top and these go to the middle too, over x plus 2 times x plus 3 over x plus 2 plus x plus 2 times x plus 3 over x plus 3. And because you can cancel out stuff like this gets canceled out with this, and this gets canceled out with this, then you end up with x plus 2 times x plus 3 over x plus 3 plus x plus 2. And when you FOIL, you get 2x. These two add together. X squared, because exponents, and plus 2x, these two, plus 3x, these two, plus 6, these two, over x plus x, so 2x, plus 5, because 3 and 2. And that is your answer, which is B. Subramaniam.
So like my whole life was a lie, then there could be 2 denominators.
Yeah.
But like fraction wise, is that possible?
Technically you could do something like 1 divided by 2, 1/2 divided by 3.
Oh, okay. All right.
Like think of it, this is a separate thing and this is a separate thing. Like the whole thing is a separate thing.
Oh, sure. There are 2 denominators.
All right. Not sure if you wanted me to hear that, but okay. All right. Anyone else have a question? Could you lower your hand if you don't have a question? Oh, well, I guess you still have a question. No, or not. All right. Anyone else have a question? Nope. All right. I'll give you guys 2 minutes to do this question, and then I'll do it myself. Also, this is a question similar to the 1/3 question before. It's just the reverse of it. So I guess whoever wanted explanations for that will get another explanation for it this time. Give you guys another minute. All right, do this question now. So we're gonna do what we did before. So you have a of -1/2 equals to x. So first thing, you want to get rid of this 1/2 here. So we multiply everything by, well, we raise everything to the squared. So you have a, well, -2 here because you want to get rid of the negative right here, equals to x to the -2. And remember, when you have a negative sign, you put 1 over whatever it is squared, and that is an answer. See. So for the algebra 2 part, I mean, not really, no, because it's just exponent rules. We're supposed to solve for a in terms of x. So when it says what is a in terms of x, it's asking for a equals to something, and a just has to be by itself. If it was asking for x in terms of something, this would be the answer already. All right, any questions? No? All right. I'll give you guys a minute to do this one. For the person who asked to go back and do the previous question again, it's really simple. We're trying to isolate for a, so a equals to something. You have a -1/2 equals to x, and I multiply by -2 because I want to cancel out the negative here and make this a 1. So these two cancel out. So I have a equals to x to the -2, which is basically a equals to 1 over x squared, because the negative makes anything like a negative exponent basically means you have 1 over whatever here. So 1 over x squared. Do you still have a question about it, Kowser? All right. I'll give you guys an extra minute to this next problem then. All right. So for this question, it's combining like terms. The entire question is just combining like terms. You have 2x squared minus 4. This negative and this negative cancel out. So plus 3x squared, negative, positive, therefore must be negative, minus 2x, negative, negative, positive, plus 7. So 3x squared plus 2x squared is 5x squared. And then you have minus 2x. And then you have what? Plus 3, I believe. And therefore the answer is A. Any questions? All right, moving on. This is a relatively harder question. I'll give you guys 2 minutes to do this one as well, and then I'll do it myself. All right. So for this question, 1 second. All right. Where's the draw button? All right. So you have to put both of these not the same form. So you FOIL first thing. You have ax times bx, which basically means a times b times x squared plus 7x because 7ax actually, because ax times 7 is 7ax plus 2bx, 2 times bx plus 14 equals to 15x squared plus cx plus 14. So two things that we could tell. A, B is 15 because they're the same thing here. When we know these two equations are the same, and the only time their x squared is there is because A and B and 15. So A times B has to be 15. And 7a plus 2b equals to c, because 7ax plus 2bx is cx. So 7a plus 2b has to be c. And then use systems of equations to solve the next part. So you have a plus b is 8, and a of b is 15. So with that, a and b can either be 3 or 5, and b can either be 3 or 5. And with that, you just start plugging in stuff. A and b equals to 15 because when you FOIL this out, you get a times b times x squared, and on this side 15x squared. So a times b has to equal to 15 because the equations are equal, and the only time where x squared is a thing is with a times b. Therefore ab is 15. And then so we plug these sets of equations, these two possible values, into 7a plus 2b equals to c, and you solve for c. So 7 times 3 plus 2 times 5 equals to 31, or 7 times 5. This would be a SAT question. This is quite literally an SAT question that was taken from the SAT. Plus 2 times 3 equals to 41. And the two answers here, 31 and 41, are the answers because we're searching for C. Any questions? All right, so systems of equations again. So you have a plus b equals to 8, and ab equals to 15. So you know a times b has to equal to 15, and a plus b has to equal to 8. The only values that match that are 3 and 5, and we don't know which is which, so we just take both, and you just plug these two values into 7a plus 2b equals to c. We get that from up here, equals to cx. So, and then once you plug it in, you get 31 and 41. Any questions still? Anyone? No? All right, move on then. All right, this question. I'll give you guys 2 minutes to do this one. All right, I'll give you guys another minute to do this question. All right. So for this question, we have ax plus 3. Yeah, ax plus 3 times bx plus 2. So first thing we want to do, FOIL. So you have ax times bx plus ax times 2 plus 3 times bx plus 3 times 2. That's just FOILing. You have abx squared plus 2ax plus 3bx plus 6. Something similar we could do here. We can just isolate the x's in the middle. So you have abx squared plus 2a plus 3b of x plus 6. So now we know that ab is a coefficient of x squared. Actually, no, this step wasn't even needed. This step isn't really even needed. So yeah, so we know that has to equal to 9x squared plus 21x plus 6. And since a of b of x squared, therefore a times b has to equal to 9, simply because these equations up here are equal. Therefore, the answer is 9. Which problem? This one or the one before this? Also, Megan.
Couldn't you just say 9 like without solving it?
Well, yeah, technically. But I guess it's just like always better to be sure. Just like, I guess like this question might be easy to tell that it is 9. However, a different question could be just difficult to do that. Yeah, sorry, I will go back and do the previous question. All right, so this question. You have first thing you do, you FOIL. I'm not going to do the entire procedure of foiling this, but what you should get is abx squared plus 7ax plus 2bx plus 14 equals to 15x squared plus cx plus 14. We can tell AB is 15 because as the next problem says, they're equal. So A times B is 15 and 7A plus 7B equals to C because C is the middle term here and 7X and 2BX is the same. And since the C's are similar, we can just take out the C's. So we have that. We know that A plus B equals to 8 because this says it. And A and B is 15. So with that, with the system of equations, we can tell that the only possible answer choices are 5 and 3 here for A and B. So with that, we can just start plugging in stuff to 7A plus 7B equals to C. So you have 7 times 5 plus 7. I mean, no, 2 plus 2 times 3 equals to 41. And you have 7 times 3 plus 2 times 5 equals to 31. And therefore, D is the answer. Sai, do you still have a question?
No, thank you.
All right. Moving forward, 2 questions now. All right, I'll give you guys 2 minutes to do this question. Oh, sorry, could you lower your hand if you don't have a question? All right, so for this question, yeah. So for this question, we want to find B. So first thing we do is we subtract the two polynomials. We like get this to become like similar to this. So you would get 9x squared minus 6x squared, so that's 3x squared. Plus, this is negative, negative, so positive. So plus 4x, 5x plus 4x plus 9x minus 1 equals to ax squared plus bx plus c. And because 9x and bx over here are the same, b is 9. Any questions? No? All right, so apparently I underestimated how fast it would go. So there I did search for another question while you guys were doing a problem. I'll write it down right here and you guys try to solve it. So 3y minus 1 over 3 negative 2 equals 2. 27y, oops, undo. 27y, 3y. And what's the value? What is y? What is y? I'll give you guys a good 2 minutes to do this one as well. Again, I didn't put enough problems for today, so I found one online while you guys were doing it, and this is it. Sriram?
Is it 3y minus 1 over 3 to the exponent of negative 2 or 3 minus 2?
Yeah, 3 to the exponent of negative 2.
Okay, thank you.
I'm just gonna put a caret here just so you know. There. My bad handwriting. I'll give you guys another minute to do this one as well. Yeah, it is 3 to the y minus 1. 3 to the y. You know what? I'll just redo that real quick. Eraser. 3 to the y minus 1. All right, another 10 seconds. All right, so for this problem, first thing we can do is, since it's a negative, we can flip the denominator to the top, because whenever there's a negative, you go back, you flip whatever side you're on. So you have 3y minus 1 times 3 squared equals to 27y times 3y. All right, so first, another thing we can do immediately. So you have 3y minus 1 times 3 squared. Oh, two things you can do immediately. So you have 3 and you have y minus 1 plus 2 because the bases are the same and you're multiplying, so you can add. So you have y minus 1 equals plus 2 equals to 3 to the third of y, because 27 to the 27 is 3 to the third of y, times 3 to the y, which again is just plus y here. So you can just take that out. And now you have 3 to the first plus 1 equals to 3 to the 4y. And because, you know, like this and this have to be equal, you can just solve for y, just ignore these, so cancel these out. So you have y plus 1 equals to 4y, and therefore y has to be, wait, did I do something wrong? I think I might have done something wrong. 1 second. 4y, and then the y plus 1 equals to 4y. Oh, yeah, I did this right. All right. So you have 1 equals to 3y, subtract, and then you have 1 over 3 equals to y, and y is 1 over 3. 27 times 3, 27y to the third. Wait, what did I do? 27 to the y is. No, so basically what I did is I turned the 27 equal to 3 to the third because that's what it is. Well, I guess if it works, it works. But what I did is 27y to the third is to y is just basically 3 to the third y, and plus y because the bases are the same then. No, this is not a calculator question. This is entirely possible by hand. There's no real calculations needed for this, but the answer is 1/3. All right, I guess that's enough for the questions today. We'll wrap stuff up a bit early today. So for next class, just like look at some English, SAT English passages. We'll be covering history passages and like typical SAT grammar stuff. And yeah, that's really it for today. I can answer any questions, just like raise your hand and I will unmute you. I get the questions from a variety of places. From Khan Academy, I get some of mine. Other ones I get from online, and some more I get from like books I have at home. If not, I guess that's it for today. You guys can go, you know, unless you guys have a question, and then I'll answer that. Just like raise your hand. So I'm not entirely sure what you mean. Like, could you just like raise your hand so I can unmute you and you can try to explain what you did? But again, if it works,